favorite friends. Welcome back to another video. This is Mrs. Berger.
And Mr. Lamb, and today we're going to talk about relations and functions.
Relations and functions, oh my! Alright, your learning target today is that you can identify relations as functions. What are these words we keep saying? This relation, this function.
They're math terms. I know relation sounds like it might not be a math term.
Relations, not those relations, guys.
We're talking about how two sets of numbers are connected together.
Let's define that, Mr. Lamb, and while I'm getting my pen, you get your pen and paper and you write this down.
Because you really need to write this down. These are kind of confusing at times.
Write it down. Okay, so the definition of a relation is how two sets of numbers, we're going to shorthand this, numbers, that's not hashtags, that's numbers, are connected or related, right? Relations. So how two sets of numbers are connected. For example.
Like the X and Y that we learned about ordered pairs in the
Coordinate
plane. Thank you. I couldn't think of that word. And the coordinate plane. So really like the X value, the Y value. And if we were going to use an example, we could say like how far from school you live and how long it takes to get to the school from your house on the bus ride. So X would be the distance you are away, and how is that related to the Y? How long it takes you to get here. Related, connected.
Right.
Kind of mean the same thing. Relation, connection, kind of mean the same thing.
That's right. So relation, again, how two sets of numbers are connected. And we usually represent those in like input, output, or that XY scenario. All right, let's look at then, well, what's a function?
Well, a function is a type of relation.
All right, write this down. Type of relation.
All functions are relations.
Yes.
But not all relations are functions.
True.
Because when you look at how numbers are related, they have to be related in a certain way for it to be a function. And that relationship says for the input, the X, you can only have one value of Y for that X. In other words, if you live 3 miles away, it can only take you 20 minutes to get to school. If you live 3 miles away, it can't take you 20 minutes, and take you 10 minutes, and take you 7 minutes. You can only have that one value.
So the X value will not repeat. So if you're looking at a set of ordered pairs, that X value will not repeat. You will only have one of those X's that pop up.
So X can only occur one time. You can't have 1, 2, 3, 1, 2, 3. You could have 1, 2, 3, 4, 5, 6, but you can't repeat that X value.
So let's look at how you'll actually be identifying whether things...
This is not the easiest thing to visualize.
Yeah, so let's look at it and how you'll actually see if something is a function or not. Sometimes you're given these kind of circles, these like input-output circles, right? So when we're looking at the input-output circles, we want to make sure for every X, right, the input, it's only connected to one Y. Did I say that backwards?
To make sure that the X can't repeat itself.
Right. So
right? As a matter of fact, even in my example, it was kind of confusing.
It's okay. Well,
okay?
let's look at it visually.
So let's look at it visually. So here we go. For -2, we have -1. For -1, we have 0, 0, we have 1, 1, we have 2. This one's simple to see it in. This one's a little harder. Notice 2 is 4.
Right.
5 is 5, and 9 is 5. So these repeat, right? If I was to list these out and put them on a graph, I would have 5 going to 5 and 9 going to 5. That's okay.
Right.
I just can't have 5 going to 9 and then 5 going to 9. I can't repeat the X value.
Right.
Because those dots would sit on top of each other.
Right, and we don't want that, right?
We don't want that.
We have to pass a straight line test, which we'll show you in a minute. So when you see these kind of input-output tables or domain range kind of circles, right? These are really just ordered pairs that are written in a different way. So I could list this out as 2, 4.
Yep.
5, 5.
Yep.
And then 9, 5. And I just look right here with that x value to make sure it does not repeat.
For
right?
it to be a function, no repeating numbers.
Or,
Doesn't matter on this side. They can all be the same.
yeah,
Matter of fact, if I draw a straight line across a graph, they're all the same y value.
yeah.
But the x value can't repeat itself.
Right, we've said that a lot, right? So if we looked at this example, this is kind of a whole nother example, another way that you would see whether or not something was a function. So as I'm looking at these set of ordered pairs, I'm looking just at the x. I have a -3, a -2, a 0, a 3, and a 4.
Must be a function they didn't repeat.
It's a function they didn't repeat. Some of the y values repeat, right? 5, 5, that repeats.
But that doesn't matter.
But I don't care.
Well, maybe we should show them an example of like what isn't a function.
Yeah, that would help, I think. Let's look at what's not a function.
So here we have numbers that are still relations. These are still numbers that relate to one another, but they're not functions.
Right.
Why aren't they functions?
Because if I look here, I have 0, -2.
So write it there, you go.
If I wrote it as an ordered pair, and I have 0, 1.
Ooh.
And if only one of your x's repeat, you just stop there and you go, well, wait,
That can't be a function.
that's not a function, right?
And here we see the same thing. Here we have a -2, and here we have a -2. We don't care that these are all different, you know, but as soon as, like she said, as soon as you get 2 of them that repeat, you can stop right there.
Boom, not a function. On a graph, if it's actually graphed for us, we can do something called the straight
Ooh,
line
I like the straight
test.
line test.
Right, so if I have the straight line test, right, so say I have this like large piece of paper, we'll just pretend. On my coordinate plane, if I take this, oh no, I touched it. Oh, give me back. Oh my gosh, it like started over. Hold on, guys. Dun, 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 dun. Okay, I'm gonna try not to touch it this time. So if I take that piece of paper and I move it, right, along the whole graph, I can see that right here, there's like, oops, God bless America. So I only have one x value there, right? I have one x value there, one x value there, one x value there. And as I'm traveling, they don't ever really cross each other, right? I'm not here and here at the same time. That would not be a function.
Because the x,
Sorry.
the x, right, because this is x, if I had an x here and an x here, well, that would violate the straight line test.
Right,
Because those two would be in a straight line with each other, can't happen.
right. So just like this one, right? I have just kind of
This is
diagonal
probably the
line.
easiest one to see it on, right? Because it's a nice straight line.
Right, passes the straight line test. But, oh, sorry.
Oh.
No, you can do it.
Okay, so this one is a not, right? Because the second you see this, you can follow this line straight down.
It passes here and here. It
Yeah.
passes here and here. Here and here. I mean, there's just tons of the ones that repeat, right? Here and here. So there's a ton of those x's that repeat with that circle. So even though it's a relation, it's not a function.
Exactly, we can still plot it, it's a relationship,
Not
but
a
it's
function.
not a function.
So functions
So-
pass the straight line test.
So all functions are relations,
All functions
but
are relations.
not all relations are
Functions.
functions. Just like sometimes it's functional and sometimes it's not.
And just remember, final thing, the x value cannot repeat.
That's the main
all
thing
you're really
to
looking
remember.
for, right? So if you're confused, there's another video that you can watch, but if not, you're gonna move on to your practice and start identifying functions.